Hello everyone, welcome to new video. In this video we are going to deal with the new topic called as construction working advantages and disadvantages and applications of the ball mill in the pharma industry. Let us proceed with the definition of the ball mill. It is defined as ball mill. It is a grinding machine which is used to pulverize the materials, particularly in the industries like mining, construction and pharmaceuticals. Function, how it is going to function means it utilizes the rotating cylinder which is filled with the metal or ceramic balls to reduce the particle size through impact or attrition mechanism. Principle of ball mill. Ball mill works on basically two principles, that is first one is impact and another one is attrition. The material which is subjected for the size reduction process is filled in a cylindrical vessel, and this cylindrical vessel contains balls which are made up of stainless steel, and this vessel is allowed to rotate on its own axis. Then due to rotation of this cylindrical vessel, the balls get lifted up and they will come back to the downwards. Due to this rotation of the balls, the material sample which is coming in contact with the balls, they get grinded due to impact. Means the balls will hit the sample. This process is called as impact. And meanwhile, during the rotation of the balls, the friction will takes place between the balls, and due to this friction, whenever the material or the sample come in between the two balls, due to friction action of the two balls, the material get grinded. So this type of mechanism is called as attrition. Here the size reduction takes place both by impact and attrition process. Construction of ball mill. The ball mill consists of various parts. The first one is cylindrical shell. Cylindrical shell, it is a hollow metal cylinder that rotates about its horizontal axis. The shell can be made up of steel, stainless steel or rubber. The next part is liners. The liners covers the inner surface of the shell, and it is made up of abrasion resistant material such as manganese steel or rubber to protect it from wear and also to protect it from the contamination of the product. The next one is balls. Balls is the main grinding media which is usually made up of steel or ceramic or placed inside the shell. The size of the balls depend on the cylinder diameter, and typically it covers about 30 to 50% of the total cylinder volume. Next one is the feed inlet and feed outlet, means feed and discharge. The material which is supposed to be ground, means which is the subjected for grinding process, enters the shell from the top and exits through the bottom after the grinding process, after the size reduction process. And the next is driving system. Driving system means a motor is connected to the hollow cylinder. In order to rotate the hollow cylinder, the motor is connected, causing the grinding media and material to tumble. Now the working process, how the ball mill is going to work. Here the first step is loading. In the loading, the material which is subjected for the grinding process is loaded in the cylindrical shell, which is partially filled with the grinding media, that is balls or stainless steel. The first step is, suppose this is the cylindrical shell in which the sample or the feed is going to introduce in the cylindrical shell, which is partially filled with the stainless steel balls. So these stainless steel balls will cause grinding process, and it is also called as grinding media. The next one is rotation. The rotation is very important step, and this cylindrical shell is connected to a driving system, or it is driven by the motor. Here is the motor which can cause the rotation of the cylindrical vessel. Due to rotation of this cylindrical vessel, these balls which are present in the cylindrical vessel, they get lifted up in the upper position, and they come down due to gravity. So this type of action will cause impact. This type of lifting up of the stainless steel balls, and it is coming down due to gravity. This will cause impact. This will cause impact effect on the feed. So whenever the balls hit the grinding material or the sample, this will cause impact. Then one mechanism is there by which the size reduction takes place. The next one is attrition. Even this in this cylindrical vessel, when these balls undergo circular motion, then there is a friction between these balls. And due to this friction, whenever the sample comes in between the balls, it will get rubbed by these two balls, and this also causes a size reduction process. This also leads to size reduction. So size reduction by this method is called as attrition mechanism. The size reduction due to friction is called as attrition mechanism. Here the size reduction takes place by two mechanisms, that is attrition and impact. And the next very important step is when in the movement of the or the speed of the cylindrical vessel is very much important. The speed of the cylindrical vessel is very much important. If the cylindrical vessel which is containing the stainless steel balls, if it is rotating in a high speed, then immediately these balls get lifted up and they will come down immediately. Only the impact will take place, there is no attrition. Only the impact will happen, there is no attrition. Due to then also we cannot get the efficient size reduction. Then if the cylindrical vessel is rotating in a very slow speed, then also the size reduction will not takes place efficiently, because due to slow movement of the cylindrical vessel, these balls will lifted up. Only the attrition will takes place, and there is a less impact mechanism, due to which the size reduction is not takes place in a efficient way. So because to avoid this one, we have to run this vessel in a optimum speed. The next one is cascading. Here the cascading means what? So how the cascading process will occurs? Let me explain regarding the cascade action. So here this is the cylindrical vessel, and these are the stainless steel balls which are present in the cylindrical vessel, and this vessel is allowed to rotate by means of motor. So this vessel will rotate by the help of motor, and due on the meanwhile or in the same time, these balls which are present in the cylindrical vessels, they also get lifted up. And due to gravity, these balls will fall down. Due to gravity. And this type of action, lifting up of the stainless steel ball and coming back or coming downwards towards the bottom level. So this type of action of these stainless steel ball is called as cascade action. This this type of action is called as cascade action. And the next one is grinding process. So by repetition of these cycles of rotation of the cylindrical vessel by the help of motor, this will cause impact and attrition continuously. Due to impact and attrition process continuously takes place, due to which the sample, or you can say the powder material, is get reduced size. That is the size of the powder particles get reduced. That is the size reduction takes place in an efficient way due to repeated attrition and impact mechanism. The next step is discharge. That is the ground material is discharged through the sorry after the size reduction process. The resultant material, after the size reduction process, the resultant powder particles are collected through the feed outlet, or you can say the discharge. For example, this is the cylindrical vessel. Here from the top side the feed is added to the cylindrical vessel, and after the size reduction process by the impact and attrition process by the stainless steel balls, uh, the resultant product, that is the powder material, is collected from the bottom of the vessel. So this process, that is after the size reduction process, the product which is obtained is called as the resultant product. They are collected from the bottom. Then we will get the homogeneous powder material, that is the all the powder particles having the same size. So that is called as the end of the process. Here there are some control parameters are there. We can control the speed of the size reduction process, or you can say the velocity of the size reduction process. So how can we control means, the first one is the speed. We can control the motor speed, so that we can control the speed of the size reduction process. Another one is ball size, that is the grinding media. That also we can controlling this grinding media, we can also control the process or speed of the size reduction process. Then another thing is feed rate. By increasing or decreasing the feed rate, we can also control the or we can have the impact on the grinding efficiency of the this equipment. Advantages of ball mill in pharma industry. The first one is size reduction. Ball mills can efficiently reduce the particle size to the desired micron range, enabling better absorption and bioavailability of the pharmaceutical products. The next one is uniformity. They ensure the consistent particle size distribution, contributing to the product quality and reproducibility. Means it can enhance the content uniformity of the pharmaceutical products due to decreased particle size. The next one is versatility. They can handle the various materials including powders, granules and pastes, making them suitable for uh, uh, desired pharmaceutical applications or diverse pharmaceutical applications. The next one is cost effective. Ball mills offer a cost effective solution for large scale production, reducing the labor and processing time. Disadvantages of ball mill. The first one is contamination risk. There is a most chance of contamination risk during the grinding process, which require careful selection of the material and stringent cleaning protocols, like careful observation should be there during the size reduction process. And the next one is heat generation. During the process of grinding or size reduction, there is a much chance of generation of heat, which can potentially affect the efficacy and stability of the product, and it is most harmful for the heat sensitive materials. Then wear and tear. The grinding media and mill liners experience wear over time, requiring regular replacement and maintenance. The next one is noise pollution. Ball mills can be noisy, necessitating appropriate noise control measures in production environment. Finally, the applications of ball mill in pharmaceutical industry, especially in the pharma industry, mills are widely used in drug formulation, grinding the active pharmaceutical ingredients and excipients to enhance the dissolution rate and bioavailability. The next one is powder blending, homogenizing powder mixtures to ensure the uniform distribution of the ingredients in the pharmaceutical formulations. And the finally microencapsulation, encapsulating the active ingredients to control the release and improve the stability, using the ball mills for practical size reduction.